Hi guys, today we're going to look at another kind of sequence. We looked at arithmetic sequences before, and now we're looking at geometric sequences. So a geometric sequence is a sequence with a common ratio between consecutive terms. So in other words, to get from one term to the next, that should say we multiply or divide by the same number each time. So if you look here, we're multiplying by 3 to get from one number to the next. So this would be a geometric sequence. Okay? So determine whether each of the following sequences are geometric. Justify your answer. I would say even like find the common ratio. If you say the common ratio is this, that's a good way to justify your answer. So if I look here, am I multiplying by the same thing every single time? And if I check it, I am multiplying here by -4. Well, does that hold all the way across? Yeah, it does. And so I would say yes, common ratio of -4. And this is how we would answer this question because common ratio says that we're multiplying by something, and we've said the value that we're multiplying by. If we look at this one, I would say, how do I get from 8 to 20, 20 to 32? There is a pattern, but the pattern is that it's adding 12. So this one is actually an arithmetic sequence, but this one we would say no, it is not geometric. They just wanted to know, is it geometric? So just like before, we have a formula. Yay! We can write a recursive formula like this, where we're just talking about like take the previous term, multiply by the common ratio. But really, this equation is very impractical. We don't really like to use that one. Because if we are asked to find the 42nd term, then we won't know it. So this equation is the better formula to use. It's the explicit formula. And it says that we take the first term. That's a sub 1. Oh, I don't want my highlighter anymore. A sub 1 times r, which is the ratio, and n is still the term number. Okay? So this is the formula we're going to use. So I'm going to jot that down every time I go to use it. All right, find the 19th term. So what are we multiplying by every time? We're multiplying by 3. So I'm going to say that my first term is 11, and my common ratio is 3. So I'm going to have a sub n equals first term times the ratio of 3 to the n minus 1. You have to show this formula. This is part of the problems. You have to show that you have 11 times 3 to the n minus 1. And so then we want to find the 19th term. So we're going to say a sub 19 equals 11 times 3 to the 19 minus 1. Well, 3 to the 19 minus 1 is 3 to the 18th power. And so we need to do that in our calculators. So when I do this and I do 3 to the 18th, I get 11 times 3, 8, 7, 4, 2, 0, 4, 8, 9. And so some of you might go, oh my gosh, am I doing this wrong? That is a really massive number. And you're not doing this incorrectly. We are going to get larger numbers for geometric sequences because this is an exponential. So remember that difference in exponential growth. With the arithmetic sequences, we're looking at something linear where it's growing at a steady rate. But with these, it's an exponential where it's 3, 9, 27, 81, and then all of a sudden it just takes off. So we are going to get a large number, and that's okay. And when we do 11 times that, we get 4, 2, 6, 1, 6, 2, 5, 3, 7, 9. So 4,261,625,379. The commas do help to just kind of make sure you've got all your numbers. So that's how we would do that. Let's look at another one. This one says find the 28th term in the sequence. So I'm going to find my ratio, which it looks like I'm multiplying by -6. And my first term, which is just 1. So a sub n equals the first term times -6. And this time I'm going to put it in parentheses because of that negative to the n minus 1. Formula done. That's the first half of the problem. The second half is to substitute in 28. We get 1 times -6 times 28 minus 1, which is 1 times -6 to the 27th power. And if we do that, sorry, I'm typing it in, -6 to the 27th, and we should get, when I type this in, I get a really weird looking answer. So I get -1.02349904. Maybe you got a few less letters. And then it says E21. So remember, what this means is that actually a sub 28 is equal to this. And if I multiply it by 1, it's going to be the same number. So it means that a sub 28, or the 28th term, is -102349904, and I'm taking that decimal and I'm moving it to the right 21 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that seems a little bit ridiculous to fill in all those zeros. If you want to go through, I didn't do quite 21, I ran out of space. That's fine. I would also be okay with you putting like -1.02 and using some scientific notation times 10 to the 21st. If that's what you need to do, that is absolutely fine. If you want to write out all these zeros, that is absolutely fine. I can figure it out and I'll know what you're talking about. Okay? Either one would be okay. Write the explicit formula for the sequence given by the following information, then write the first 5 terms. So here, they're not even giving us a sequence necessarily. They're giving us a sub 1, they're giving us r, saying write a formula. So a sub n would equal 5 times -2 to the n minus 1. Again, those parentheses are an essential part, because if I raise -2 squared, that's -4. But if I do in parentheses, it's +4. So the parentheses matter. And then it says write the first 5 terms. Well, I know what the first term is, 5. And then our pattern is that we're multiplying by -2. I could substitute those in. I could also look here and say 5 times -2 is -10. -10 times -2 is +20. This would give me -40, and that would give me +80. There are my first 5 terms. And again, I could check it. I could plug in 5 up here, and I would have -2 to the 4th power, which is 16, and 16 times 5, which is 80. One more. All right, write the explicit formula. So let's start with that. A sub 1 times our common ratio to the n minus 1. So there's our formula. Then find the first 5 terms. Our first one is 54. And then what this is saying is multiply by 1/3. But if we multiply by 1/3, that is the same as dividing by 3. But with common ratios, ratio is always in terms of what we're multiplying by. So I've got 54. My next term will be 54 times 1/3, or 54 divided by 3, either one. That would give us 18. Divide by 3 again, that would give us 6. Divide by 3 again, that would give us 2. And then I'm going to start to get to some fractions. I'm going to have 2/3. And that's okay. Just leave it as a fraction. Fractions are your friend. But yeah, so this is geometric sequences. Review any part of this that you need to, and then you can go ahead and move on to your assignment for today. Let me know if you have questions.